So Sheckman used yeast genetics, and he was studying temperature-sensitive mutant yeast, and he could morphologically, with a microscope, see that some of the vesicles in the mutant yeast were building up in certain parts of the cell. And he understood that that disturbed the traffic. And he went on to identify the genes that controlled this traffic. That was a pretty bold approach, because at the time, people didn't necessarily think that studies of yeast would be of relevance for mammals. Rothman took a really bold approach. He studied this process in a test tube. Now that approach was met with some skepticism, because people thought that this traffic would be dependent upon the proximity of the compartments with each other. Therefore, you theoretically wouldn't be able to break up the cell, because you'd need to have an intact cell. But Rothman broke up the cells and studied this in a test tube, and he could show that even in a reconstituted system, he could build up this interaction between proteins, the protein machinery, and study the traffic of these vesicles in broken cells. And Sheckman, when he came on the scene, I think he recognized that calcium could be a sensor.
Sudhoff, do you mean?
Sudhoff, yes, correct, Sudhoff. Sudhoff came on the scene. He recognized that calcium could be a sensor. And he was faced with a situation where all the building blocks were unknown. And so his job was to really put functionality and understand what are the building blocks that the calcium binds to, and how does that release vesicles in a temporally controlled manner.